Okay, radiation pattern means what? It is always function of angle. It is always function of angle where r is constant. Where r is constant. So when you are drawing on the diagram, you have to normalize the value. So then see here there is no distance is constant. So simply it is giving you the how much power you will receive when you are at this angle. When you are moving here, your angle will vary. When you are here, you are getting maximum power. As you go along this, you are getting less power. That is the idea of this diagram. That is the idea of the radiation pattern diagram. It is always function of theta comma pi, where r is constant. Okay, r is constant. Next, radiation pattern. There are again radiation pattern means locus of the received electric field, or otherwise sometime radiation pattern can also be drawn for power. That is called as power pattern. Again, even if it is if field pattern or power pattern, that is always function of theta comma pi, where r is constant. Okay, so again we have seen what is near field, what is far field. Okay, in general there are two type of field, near field and far field. Then definitely there should be something. If antenna is here, okay, so there should be some dividing line to divide near field and far field. Okay, if your receiver is okay within this field, then that is called near field. If receiver is beyond this line, then that is called far field. Okay, near. Okay, this is near field, then this is far field. Okay, so then there should be some distance. That distance is r. If r is greater than 2d square by lambda, then you are in far field. There you will get radiated field or active field. Okay, that is for Fraunhofer far field zone. If you are within this region, near field region, then you will get reactive field. You will not get actually useful field. You will get some reactive power. Okay, but actually that is not useful. Okay, so not used for communication purpose. Only radiated field or active field is used for the communication purpose. Okay, then we'll see in radiation pattern itself. We'll go a little bit deep. Okay, and again another dividing line to divide near and far field is lambda divided by 2 pi or 0.16 lambda. Okay, there is a derivation for this. I'll do it when we discuss about dipole and all. I'll do that. Okay. Okay. Now we'll see the radiation pattern a little bit detail. Okay, radiation pattern. Now, in general, radiation pattern is of 3D nature, but when we are drawing on 2D paper, okay, we will fix something. Okay, now radiation pattern we are going to draw it in a 2D format. In 2D format, okay, in 2D format, the one way is we can draw the radiation pattern in a azimuthal plane. We can draw the radiation pattern in the azimuthal plane. Azimuthal plane. Okay, when we draw a radiation pattern in azimuthal plane, what is constant for azimuthal plane? For horizontal plane, what is constant? Theta is constant. For horizontal plane, what is constant? Theta is constant. That value is 90 degree. The another name for azimuthal plane is what? Horizontal plane. Okay, horizontal plane. Okay, already if I start the radiation where radiation, if I start discussing about radiation pattern, already r is constant. Now, when you draw the field pattern in azimuthal plane where theta is constant, so in azimuthal plane, when you are drawing the radiation pattern, that is always function of phi. That is always function of phi. Or otherwise, I can also draw the radiation pattern in the vertical plane. That plane is called elevation plane. Okay, how many vertical plane is in the elevation plane? Vertical plane you will get when you vary your pi. Pi equal to 0 is one plane, or pi equal to constant. You can take pi is equal to any value. Then you will get what? A vertical plane. For simplicity, I will give you one idea. Suppose if you have a sphere ball like this, okay, you have to make two of. Once if you cut horizontally, there is the only way. In this way only you can cut. Once if you are given option to cut only horizontally, this is the only way to cut the ball to make it as a 2 off. Now what I do, I will give you ball. You can cut vertically. Okay, you can cut vertically. How many possible way you can cut vertically? Is it the only way or there are many ways? Please tell me. ஒரு பால் இருக்கு சார், ரவுண்ட் ஷேப்ல, ஸ்பியர் ஷேப்ல, ரெண்டு ஆஃபா கட் பண்ணணும். பட் ஆனா இப்போ உங்களுக்கு நீங்க வந்து வெர்டிகலா யூ ஆர் கோயிங் டு கட். எத்தனை பாசிபிள் வழியில கட் பண்ணலாம்? ஒண்ணே ஒண்ணா இல்லனா இன்ஃபினிட் வழியா? மோர் தென் ஒன்?
2 sir.
Only 2. Yes, what about others? Yes, there are many ways, sir. You can cut in any way. Please imagine properly. If you have spear, if you are given a chance to cut vertically, there are many ways. You think of apple. If you want to cut the apple vertically in 2 parts, you are thinking that that is the only way. You can rotate the apple in any way you want, then you can cut it. But once if you are given opportunity to cut only in the horizontal way, this is the only way. This is the only way you can cut. Here you have many ways. Okay, you can cut many ways. Okay, you can cut like this, or you rotate the apple and you cut. You can cut anywhere you want. Okay, there are many ways possible. Okay, so in the elevation plane, when you want to form an elevation plane, so your pi can be anything. Okay, that means pi has to be constant, not necessarily to be some value. Pi can be anything from 0 to infinite. Sorry, 0 to 2 pi. Pi can be anything, but in reality, not to make a confusion, okay, we'll always take, okay, pi is equal to 0 degree. Not to make a confusion, we'll always take pi is equal to 0 degree, but in reality, pi can be anything. Okay, so this elevation plane is called horizontal plane, or otherwise this is vertical plane. Okay, this is vertical plane. Purida sir? Yes. Okay, so now for isotropic radiator, okay, what will be the field pattern? Once if I take isotropic radiator, okay, for isotropic radiator, okay, isotropic radiator means you imagine some balls are sphere type. You imagine some ball of sphere type. Okay, like some ball of sphere type. Okay, that is actually a 3D radiation pattern, ball of sphere type. But actually what we want, we want to draw a 2D pattern. We want to draw a 2D pattern. Okay, for 2D pattern, suppose if I fix theta is equal to 90 degree, then what is the meaning of this one, sir? I will cut the ball, I will cut the sphere like this. Okay, now the antenna is here. Okay, now the antenna is here. Now I will stand here. So now my antenna is here. If I stand here, I am receiving some power. If I stand here also, I will receive same power. So wherever I go, I stand in the circle, I will get the same power. I will get the same power. That means what? So for this, the radiation pattern diagram is simply circle. Radiation when theta is equal to 90 degree, what is the radiation pattern of isotropic radiator? Simply circle. Similarly, when I take, okay, when I take pi is equal to constant, or not to make a confusion, pi is equal to 0 degree, that means what, sir? I have to cut the sphere vertically. Once if I cut the sphere vertically, my sphere may look like this. My sphere may look like this. Okay, now my question is, if my antenna is in the middle portion, because antenna will always be available in the middle of the sphere. Now I go along the circle. I go along this dotted line. I stand here. 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 So wherever I stand, I will get the same power. Okay, I will get the same power because this is of sphere shape. Okay, sphere. Whenever you have a sphere, you cut vertically or you cut horizontally, always you will get a circle. So now also the radiation pattern is circle only. So for isotropic radiator, you are having the radiation pattern of, okay, you are having the radiation pattern of circle, okay, in both the horizontal plane and as well as in the elevation plane, as well as in the elevation plane. Okay. Is doubt irukka sir? Radiation pattern of isotropic radiator. But in future, we'll draw the radiation pattern for lambda by 2 dipole and quarter wave monopole, and for some other antennas and all. There you will have some different shape. There you may get circle in one case, you may not get circle in another case, you may get some other diagram. It all depends on the what is the actual 3D shape of the antenna. What is the actual 3D shape of the antenna? Okay, once if it is isotropic radiator, Please imagine a sphere. Please imagine a sphere, because sphere shape is the radiation, 3D radiation pattern of the isotropic radiator. If it is a 2D format, then simply that is a circle. Simply that is a circle. Okay. Next, what is average radiation density? Okay. Please note down, density is different, intensity is different. Okay. There are two varieties. Now we'll see average radiation density. Okay. Average radiation, okay, density. Please do not worry about this average, because whenever you have average, what is the meaning of that? Not only here, even in circuit analysis, what is the meaning of average, sir? See, meaning of the average is, if it is DC, no problem. Okay, DC, even if you take average, okay, see, average